Okay. Next in this part, I will explain you about the basic or the common structure of the device that make the diode. This is what we call it PN junction. So in the previous video, I have shown you how the uh, diode look like, the symbol of the diode, and then I have shown you the current voltage characteristic of the diode. So basically, diode can only allow one direction of current flow. So how the diode can operate that way? This is by using, we call it PN junction. So this is the PN junction. So here the first word in the term is junction. What junction means? Junction means the boundary or interface between two medium or two materials. So from the name we have the P material, and then we have N material, and then the junction is referring to the interface between P material and N material. So actually P referring to the P-type semiconductor, and then N referring to the N-type semiconductor. So PN junction means that interface between P-type and N-type semiconductor. So the very simple structure of the PN junction should be like this. We have P-type and N-type. The junction is at the interface. Okay, so and then we need to do some revision in order to discuss on the operation of the PN junction. We need to be able to explain some basic terms or basic concept. So the first one is conduction electron and hole as a carrier. So we know that the electricity that flow inside the semiconductor actually is due to the movement of the electron or due to the movement of hole. So we call the electron or hole as a carrier. And then the conduction electron and hole, how they are produced. They are produced or they are generated through a process we call it electron hole pair generation. So when one free electron is generated, there will be one hole form, one hole form because this is in pair. So and then next, this one is very important since in PN junction we are using P-type and N-type silicon. N-type and P-type silicon is referred as extrinsic semiconductor, which is not a pure semiconductor. We have added some impurities inside the semiconductor in order to make it N-type or P-type. So we add the impurities or foreign atom, we call it dopant, through a doping process in order to make it N-type and P-type. What is N-type and P-type? So this is show you the image of the P-type and N-type. So P-type is the material, or the P-type silicon means that the silicon that have many number of hole compared to the number of electron. So you can see here, this is inside the silicon. We have for the P-type silicon, this one is hole. This one is hole. So and then the black one is electron. If you count the hole and electron, you can say that there's many hole compared to the electron. So the hole is majority carrier, and then the electron is minority carrier for the P-type silicon. And then inside this silicon, we have impurities. Okay, for the P-type, the added impurities or the added dopant is trivalent. Okay, trivalent is the added. This is for the P-type. For the P-type is trivalent. Okay, trivalent means that it has three what? It has three valence electron. Okay, it has three valence electron. So, but when the trivalent atom fit into the silicon, so there will be the 3-valent atom can be seen as a negatively charged ion. Negatively charged ion. So this is because of the 3-valent have 3 valence electron, but the neighboring silicon actually have extra electron. So the 3-valent seems to have more electron, so it has negative charge. Okay, and then we have the n-type, n-type, the picture is something like this. N-type, the majority carrier is electron. So this black one is electron. There are many electrons compared to the hole. Hole is the white one. So this is n-type. So where the electron come from? Electron come from the pentavalent. Pentavalence means that it have 5 valence electron. So we know silicon has 4 valence electron. So when the pentavalent is added inside the silicon should have 4, but pentavalent have 5, so it has extra 1 valence electron. So this 1 valence electron will be released and become free electron. And then when the valence electron is released, so the pentavalent will have less electron compared to the proton inside the nucleus. So it become a positive charge because less electron. Okay, so this is important concept that you need to digest or to understand in order to explain the operation of p-n junction. I think I suggest you to read and then to find your own reference and read and then try to understand. Maybe it will take some time, but it will worth it. So try to read and understand this concept. Okay, so anyway, in summary, p-type will have more hole, less electron, and then they will have a negatively charged ion. And n-type will have more electron and positively charged ion. Okay, what happened when we combine the p-type and n-type? Okay, when we combine p-type and n-type. Okay, in the previous slide is the p-type and n-type is isolated, but now we combine them, p-type and n-type. So the first thing happen is there will be a diffusion. Okay, there will be a diffusion process. Okay, what is diffusion process? Diffusion of process is the movement of a particle from high concentration to low concentration. High concentration to low concentration. For example, let's say you have in your house, when your mother or when your wife cook something, they will produce smell, right? You produce a smell, the vapor, and after some time the vapor will go to the living room. It will move to the living room and then you will smell the cooking. So this is the diffusion of the smell, the diffusion of the vapor. So same here, same goes in this case. Because the n-type have many electron and p-type has less electron, so the electron tend to move towards the p-type, towards the less concentrated region. So the electron move from n-type to the p-type. So this is diffusion. Okay, when the electron arrive at the p-type, so what happen? It will meet hole. There will be hole. So electron and hole. And then when there is electron and hole, there will be a process, we call it recombination. Electron hole recombination. Okay. Electron-hole recombination is a reverse process of electron-hole pair generation, or generation of electron-hole pair. Okay, the process, this is a reverse process of generation of electron-hole pair. Okay, the generation of electron-hole pair is by releasing the electron and then producing the hole vacancy. But now in reverse is the hole go back to the vacancy, and then what happened? The electron and the hole disappear. So there will be no more electron and no more hole when the electron hole recombine. So what happened? What happened is nearby this junction or nearby the interface, there will be no electron and no hole. There is no, for example here, no hole and then no electron. Why? Because electron here already move towards the p-type and then recombine, and then hole here disappear because of the recombination of electron and hole. So there is no electron and no hole. So what left is only a ion, only on the ion, negatively charged ion at the p-type and positively charged ion at the negative side. So this is the region where there is no electron and no hole nearby the junction. We call it a depletion region. Okay, this is depletion region. The depletion region is the region at the junction of the p-type p-n junction, and then there is no free electron there, then there is no hole, so means that the carrier deplete. The word depletes means there is no more, there is become disappear. Deplete means disappear. So depletion region means that the region there is no hole, no carrier, no electron. So what left is at the p-type is negatively charged and n-type is positively charged. So when we have this localized, when we have this localized charge, this is negative charge, and then this positive charge, what happened? There will be a electric potential, electric field. It will form something like a battery. So there will be an electric field and electric potential at the junction. Okay, why this electric, what we call it electric junction, electric potential, very important in the diode operation? Because of the electric potential impedes or restrict the movement of the electron crossing the junction. So what will happen when this depletion region forms? There will be electron. Actually, there are many electrons still inside the n-type. So they also want to cross the junction. But what happened is electron is negative, and then we have this negative ion. So this negative ion, or we in the form of electric potential or field, will impede or restrict the movement. So this cannot be done. So the electron cannot cross the junction because of the negatively charged dopant at the p side of the depletion region. So how we can make this electron, how we can allow the electron to move across the junction, is by applying external DC voltage. And then the applying external voltage need to be higher than this existing electric potential. So we need to apply a voltage, external voltage, in opposite direction of the form built-in potential. Okay, and then the value of the voltage should be higher than the form built-in potential. So in case of the silicon PN junction, the potential is around 0.7 volt, and for germanium, the potential is 0.3 volt. So we need to apply higher than 0.7 in order to allow or to produce a current flow. For germanium, we need to apply higher than 0.3 to allow the current flow.